Hi guys, this is Catherine Rabik, Hrabik. This is my code walkthrough for the final project. So let's just kind of get into this here. I'm just going to kind of skip past part of this. This is just reading the data set in, and I did keep the index separate, but that was just to help facilitate splitting into test and train later. So the first thing I did was I kind of plotted the data because I wanted to see the distributions here. So you can see there's some definite patterns here. You can see some of them look like they're definitely correlated in some way. But I did see here that it looked like there was some noise going on in these two features because you can see everything else is up around 0, and then we have these ones that shoot way down here. So you can kind of tell that that's probably not right. So I did isolate those, feature cells, and you can see that these values are way off from the rest of the data, and that's kind of what's causing that. Now, just it's not necessarily for sure that it's going to improve learning, but I did want to get rid of that noise just to see what would happen. So all I did was I kind of took the easy route and I just set them to 0. Another thing I could have done is taken like the mean or the median of that column and use that to kind of bring those values back within the right range. So what I did here was I plotted again, so you can see now there's like a little bit more of what looks like a pattern for the data. So everything looks like it's working correctly here. Now this last one, I'm not really sure what's going on here. I'm not sure exactly, what this distribution here is telling me. It seems almost like there's, not really a pattern that might be observable out of that. Now that might be true, that might not, but I was really interested to see what would happen if I took that feature out. So I actually completely removed that feature just to see what would happen. So after that, I just normalized. One thing I did, here I normalized from 0 to 1 first off, but I normalized the y values separate so I could use that later on to inverse the normalization on the prediction. The time function is pretty standard. I did one thing here. I actually pass in the index. So when, I'm running this and I'm trying to essentially transform my data into the correct format for the LSTM function, when I have the data returned, I have it returned as a data frame with the original index just to kind of help me keep track of, where everything is for the train and test split. So I just run the time function, my formatting on the values, and I pass in the index here. And then I check the shape when I'm done just to make sure it's what I'm expecting, which it is. Now, this might look a little bit different. It was originally 336, but since I removed that feature, that's why that number changed. So that is correct. It's just with that feature removed. So all I'm doing, I'm just splitting the data based on the dates, transforming them back into vector representations, checking to make sure, the shapes are all what I'm expecting. Again, we're seeing that 312 instead of 336. Now here, usually the value for this is 14, 14 features for the data dimensions. Mine's only 13, so I changed that. And then we reshape the data to become 3-dimensional. So we need to account for those, time steps in the features. So checking my shape again, mine's 13 instead of 14. And then after that, I really just built the model. So one thing I did notice here is out of all my different combinations, a base model actually seemed to be the best. For whatever reason, I'm not actually sure, but it was the best fit for this data set. It was just a really basic model. I guess in this situation, it's more of a less is more type thing. So out of the combinations I chose, I chose, anywhere between, I think it was 1 and 512 nodes. I tried recurrent dropout, regular dropout, adding a dropout layer, adding more dense layers. I tried the GRU layers as well as the one-dimensional convolutional layers. I also tried different loss functions, and also different optimizers. So instead of Atom, I at one point was using RMSProp because that was another one that was considered good on the recurrent neural networks. I also did mess with the like the learning rate and decay from within the optimizer. And I did try epochs up to, I think it was like 200, as well as different batch sizes. But when it, all was said and done, the best model that I got was just the most basic. All right, so after that, I did my predictions. I reversed the scaling to put them back to normal. And then I plotted it, and you can see it's still a little bit bumpy here. We might still be having some issues, either maybe some noise is causing a problem, maybe it's just overfitting. But this actually ended up being my best model, which I believe got a score. I think it was 0.48. So then I just put all my data in a data frame and send it to CSV to upload for Kaggle, and that was really it. So, I mean, some of these things here was more just exploration. So the things I did with removing a feature and taking out the noisy data, actually didn't improve the model that much. It did improve the model a little bit, but not as much as I was expecting. So really this was all about just trying different combinations and seeing what did the best for me. So this one was the best for me. All right, well, that is it. I hope you guys have a wonderful winter break, and thank you.